Projects. In this video, we are going to explain about a project titled Link Prediction in Evolving Networks based on Information Propagation. So now coming to the introduction part, link prediction in evolving networks based on information propagation is a promising research area that leverages information diffusion mechanisms to forecast the formation of new links and dynamic networks. By understanding the patterns of interactions and influence within the network, link prediction methods offer valuable insights and practical applications across diverse fields. By analyzing the past history of the network, such methods can learn patterns and trends in how links form and propagate over time. These learned patterns are then used to predict the likelihood of future links between nodes. So now coming to the objective part for this project, the evolving networks based on the information propagation of the link prediction is to develop predictive models that utilize information diffusion and network dynamics to anticipate the formation of new links in dynamic networks. By understanding the underlying mechanisms that drive link formation over time, this objective not only enriches our knowledge of complex systems but also has practical implications in diverse fields, paving the way for better informed decisions and strategies in an ever-changing world. By predicting future links, researchers can gain insights into the network's structural changes, helping them model and predict various phenomena such as the spread of information, the formation of social ties, or the emergence of collaboration in evolving social, technological, and biological networks. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, upload network data set. So here in this step, a network data set is collected and uploaded into the system. The network data set represents a graph with nodes and edges, where nodes can represent entities and edges represent connections or relationship between these entities. Second, calculate unconnected nodes. After uploading the network dataset, the system calculates the unconnected nodes. Unconnected nodes are nodes in the network that do not have any edges connecting them to other nodes. Identifying unconnected nodes is essential for understanding the overall structure and sparsity of the network. Third, run influence set algorithm. The influence set algorithm is a computational method used to identify the influence spread in a network. It determines the set of nodes that have the maximum influence on the rest of the network. By running the influence set algorithm, the system identifies influential nodes and their potential impact on the overall network dynamics. Fourth, CIS link prediction using naive method. So here in this method, the common neighbors based influence set, that is CIS, is a link prediction method that uses the concept of common neighbors to predict missing or potential edges in the network. The CIS method leverages the idea that nodes with common neighbors are more likely to have a connection in the future. The naive method implies that this prediction is made without considering any upper bounds or constraints. Fifth, advanced link prediction using CIS and upper bounds. In this step, the CIS link prediction method is enhanced by incorporating an upper bound or constraint. This constraint may be related to the maximum number of common neighbors or other factors that limit the prediction. By introducing an upper bound, the link prediction becomes more refined and realistic, reflecting the potential limitations on link formation in the network. 6. Execution time graph. During the execution of the link prediction methods, the system records the execution time for each algorithm or step. The execution time graph visually represents the computational efficiency of the algorithms and provides insights into the scalability of the link prediction methods concerning the network size and complexity. 7th, close application. After the link prediction tasks are completed, the application is closed, ending the process of analyzing the network dataset, predicting potential links, and evaluating the influence set. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some dataset over here. And here this link prediction is the main Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload network dataset button to upload the dataset. So here I am selecting this sample small dataset over here, and now click on open button to upload the dataset. So here on this screen we can see network contains how many nodes, edges, and its in and out degree connectivity. So now click on calculate unconnected nodes button to find all those nodes which has missing links. So here on this screen we got all missing links as 1 to 6 and has no connectivity, so that link is missing, and we can predict future link for 1 and 6. To predict, first click on run influence set algorithm button to find all influence nodes on nodes which has high connectivity. So here on this screen you can see that 1, 2, 5, 6, 3, 4 and 7 are the influence nodes which has high connection with one another. So to understand in this graph, all nodes are connected with one another. So all nodes become influence node, and this may not happen for large data sets. So now closing this. Now click on CIS link prediction using naive method button to predict link for missing link nodes. So here on this screen, for unconnected node 1 to 6, we can see predicted node links are 2 and 5, which means in future 6 can connect with 1 by using link nodes called 2 or 5. I am displaying similarity score between common nodes set found. Similarly, I am displaying predicted links for all missing or unconnected nodes. So now click on advanced link prediction using CIS and upper bound button to get predicted link output. So here on this screen you can see that with advanced algorithm, and now here output with sample small data set, and now we will upload, we keep both data set and see the output. So now click on execution time graph over here. So here in this graph you can see that here x-axis represents the time over here. So now, and also you can see that here y-axis represents execution time, and from this graph we can conclude that advanced algorithm taking less execution time compared to old naive base. So advanced algorithm is less than the old naive base. And so now closing this graph, you can click on close application for closing this application. So now coming back to the conclusion part. Overall, link prediction in evolving networks based on information propagation holds immense promise for advancing our comprehension of complex systems, and its continued exploration will undoubtedly contribute to a more insightful and informed understanding of the dynamic interplay between nodes and links in evolving networks and biological systems. Link prediction enables the study of disease spread, protein interactions, and ecological dynamics, providing insights into critical processes in life sciences. Furthermore, link prediction in evolving networks has practical applications in recommendation systems, personalized advertising, and content dissemination.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.